Oh, hi Year 7s, it's Mr. Freiberg here, and this is a quick catch up on the lesson that we missed back in week 1, which was an introduction to algebra. So this was supposed to be the live lesson back on Monday the 22nd, I think it was, Monday the 21st of April, thank you. And this was as I said, the lesson that I missed, and unfortunately, I missed it, unfortunately, due to circumstances beyond my control, but it is an important lesson and a lesson that I think we should go through really quickly. So this is a quick little introduction video, a little video to give you an introduction to some algebra concepts, which we'll be talking about as we go through the weeks. So at any time, as I said, you can pause these videos and write something down if you need. You can also use the class notes, as we've said numerous times. But if you are using your book, there's the learning intent. It's to identify and recall some algebraic terms and conventions, and the success criteria you can see there as well. As I said, pause at any time if you need to. Okay, so why are we looking at algebra? Well, as you can see there on the screen, if I go straight to the underlined bit, it's the fundamental building block of mathematics. If you know anything about algebra, then you should be able to do mathematics. You'll notice there at the top of that paragraph, it says humankind would never be able to travel to the moon without algebra. If you have watched movies such as The Dish here in Australia, or The Hidden Figures, featuring all of the mathematicians that got the Apollo 11 crew to the moon, I would highly recommend you watch those, but you will notice that there is lots and lots and lots of algebra. So what actually is algebra? It's a mathematical language that uses letters and or symbols to communicate rules, describe patterns, and to solve problems. And I think one of the big ones there for me is the describing patterns. Okay, so any sort of pattern of numbers, of maybe shapes, anything in nature, you can use algebra to describe those patterns. When we use algebra is we put back together a problem or to find a solution, and that's the most common application that we have in school, is to find a solution. And where is algebra used? Because there's quite often a question, well, where are we going to use that in real life? And you'll notice that there are some simple uses that we've found in the textbook. I would recommend that you take the time to read through that slide, and if there's any important notes there that you would like to do or like to write down, pause the video and write those down. This is a really, really important slide so that we know what we are talking about. And I would strongly recommend that you read through this slide with me, and then you pause it and you write down all of the terms and all of the definitions that you see on this screen, because this is basically the language of algebra that we'll be using over the next few weeks. We start with something that's called a pronumeral, and you may have heard of this one once before. It's a letter or symbol that takes place of a number. You may have heard of the word unknown. For example, we might ask you to solve to find the unknown. It's the actual number or the answer that pronumeral represents. So for instance, in week 3, we'll be solving equations. That answer, when we solve the equation, actually gives us the value of the unknown. A variable, the next one down, describes the unknown number if its value can change. And if you look at the prefix in the word variable, you've got the word vary. And so we say that if its value varies, it becomes a variable. Now, if you have a number by itself without a variable or a pronumeral, that's called a constant. The number that sits in front of the letter, or the variable or the pronumeral, is called a coefficient. The really, really important point to note about the coefficient is the sign is included. Now, what do I mean by the sign? I mean like a plus, so a positive number, or a negative number. So for instance, we might have something like positive 2a. So that means 2 times a, all right? And the coefficient in that particular term is the 2 out the front, and as I said, it includes the sign. So that's our coefficient there. Another example could be, say, negative 7y, and now the negative is included with the 7, and so that's why I've said there that the sign is included. I used the word terms in there, so what actually is a term. A term is a combination of pronumerals and coefficients, or it's just a constant by itself. So these two here are terms, and if I just wrote a random number like the number 3, that's a constant. It's also a term, so it also gets included. Now, an expression is when we've got several terms, perhaps added, subtracted, multiplied together. It's a number sentence, but there is no equal sign. So a very simple example of an expression could be, say, 3x minus 2. That's an expression. Okay, it's a couple of terms added together. If, however, we had that 3x minus 2 was equal to something, for example, 3x minus 2 maybe equals 10, then that now becomes this last thing down the bottom, which I'll color in blue. It becomes an equation. Okay, so an equation is when we've got two expressions joined together by an equal sign. So in other words, we've got a left-hand side and a right-hand side. Now, as I said, you might like to pause the video to make sure that you get everything down off that screen that you see carefully. A couple of little points I've highlighted or underlined, I would encourage you to do the same. I'll see you on the next slide. Okay, just another couple of terms and definitions. As well as those on the previous page, we also have the 4 basic operations when it comes to maths. So we've still got plus, we've still got minus, we've still got multiply, and we've still got divide. However, just be mindful that there are lots of different ways to describe those 4 operations, and you can see them on the screen. You might like to pause the video and you might like to write those down. What I'd also challenge you to do, though, is to maybe go searching even further and see if you can find some additional terms and definitions that go with those 4 operations, and you can write them down in your notes as well. Okay, some conventions. Now, convention seems like a really, really big word, but this is basically a little set of rules that we have when it comes to some algebra or using algebra in the mathematics world. For example, there are the first convention that you can see there is that if we are multiplying a number by a letter, so as you saw on the couple slides back, a coefficient and a pronumeral, we actually leave the multiplication sign out. So the first little convention is we leave it out. So something like 2 times n actually gets written as 2n. For example, if we had, say, take me back to that previous example where I had 3x. 3x means 3 multiplied by x. So we actually don't have the multiplication sign written in there. The next one down is with dividing. So when we divide, we actually replace the divide by symbol with a fraction bar. So quite often you might hear your maths teacher say that the line in a fraction means divide, and you can see that that example, n divided by 2, just gets written as a fraction with an n on the numerator and a 2 on the denominator. So I would say n over 2. The next little convention is that numbers are always written in front of pronumerals, so that is the coefficient always gets written first, as you can see there, like 4g. And as I try and tell my classes, remember your mobile phone coverage. It's called 3G, it's called 4G, it's called 5G. The number goes first. Just a little hint there. Back to multiplying, another little rule about multiplying is that if we have more than one pronumeral multiplied together, we write the pronumerals in alphabetical order. So for instance, if we've got the pronumeral f multiplied by the pronumeral c multiplied by the pronumeral q multiplied by the pronumeral b, well, we don't write any of those multiplication signs in, and we actually rewrite that as not F, C, Q, B, but we write it in alphabetical order B, C, F, Q. That's a little mathematical convention that we need to remember. Brackets show addition and subtraction. That needs to be done before multiplication. That's just basic order of operations. And constants are usually written last in an expression. So you know I've put a couple on the board already. Here's another one, 6a plus 7, that's an expression, and the constant is written last. Now again, please write down the notes that you see on the screen there, and if there's, you'll notice as well that I have highlighted or underlined some key points. Take the time to do the same and pause the video, and we'll see you on the next slide. Okay, so let's have some practice today at writing expressions. So we've given you basically a little crash course in some terms and definitions when it comes to algebra. Let's actually do some algebra. So this is a simple little example just to show you. So the example is I have a bag of lollies that we are going to call L. Okay, so we've got L lollies in our bag of lollies. We don't know how many lollies are in the bag, and you are given an extra 5. Now, the first thing I need to think about is what operation, plus, minus, multiply, or divide, does the word extra mean? So that means I've been given an additional 5 lollies. So it pretty simple means that I'm going to plus. So if I've got my original packet of lollies, which is L, and I've got another 5, then my mathematical expression would be L plus 5, as you can see on the screen. Then you are given another bag of lollies. So that means I have another additional bag. So as well as my L plus 5, I now have to add another L to it. So I've got L plus 5. Now you see this L plus another L. That's kind of like saying one L plus another L means I've actually got 2 L's. So to make it easier, I combine those 2 L's together and I can write it as 2L plus 5. So 2 bags of lollies plus 5 more. I'm then given an additional bag of lollies, so another bag of lollies, and I can write that, if I follow this pattern up here, as L plus L plus L plus 5. Well, what do you think would be the shorthand that goes in here? If you're using your book, write something down. If you're reading this, if you've got the notes there, maybe just make a little note off to the side. By the time I finish rambling here, hopefully you have an answer written down, and it looks something like this: 3L plus 5. Now, if you managed to do that yourself, well done. You've just written your first algebraic expression. One of many. I'll give you the tip. So let's do a quick I do, we do, you do. Now, you don't need to write this one down. Let's say old mate Simon, he has X fish in his aquarium and he buys 10 more fish. So I need to think about, what does the word more mean? It means that I'm going to add 10. So how many does he have altogether? So as I said, more means to add, and so I would write my expression as X plus 10. Let's try one together. I bought a packet of footy cards down at the paper shop the other day, and there were R cards in that pack. How many cards are there in 3 identical packs? So I didn't buy one, I bought 3, and each of them have the same amount of cards, which is represented by the letter R. Now, I know that I need to use multiplication. So I'm just going to pause for a minute, well, maybe 30, actually probably only 10 seconds. And I want you to see if you can write down what you think the expression is for this one. 5, 4, 3, 2, 1. What did we write? We wrote down R times 3, or remember, using algebra and mathematical conventions, you would write that down as 3R. If you had R times 3, well done. If you had 3R, doubly well done, because now you've applied algebra and our mathematical conventions. Let's try another one together. Sonia has N dollars in her bank account, so she's got some amount of money. She withdraws $100. How much money is left in her account? So there's a key word here, which is withdraw. Think about what operation withdraw means. It means we're going to subtract. So now I've got to write an expression with a subtract in there. If she starts with N dollars and withdraws 100, we'll go N take away 100. And hopefully, in the time that it took me to say all that and press those buttons, you may have written something like that down. Folks, that's really all we need you to do today in the textbook. You'll be writing some expressions, you'll be writing down some pronumerals, you'll be writing down some coefficients. You'll find these questions on page 263 to 265 in your textbook if you're at school. It's unit 5.1, and you'll notice it looks like there's a lot of questions there, but they're all pretty simple and there's not too many parts to them. So 1, 2, 3, 7, 8, 9, 10, 17, and 19. That's all I need you to do. So for example, questions 4, 5, and 6, I don't need you to do because they're a little bit repetitious. If, however, you have got all of those questions finished and you think you want to go back and try more, then you can certainly go back and try the other ones that I haven't written down. Be mindful, though, that as we go through those questions, they will get harder, up to some problem-solving questions. If you don't have a copy of your textbook, over the next few slides, you'll actually find those questions, and you can pause this video on those slides so that you can do those questions. Alternatively, if you have a copy of the class notes, you'll find those questions there. And the other alternative is that back on the eLearn classroom, I actually just have a specific link for the textbook exercises. So there's question 1 and 2, just some fluency, again writing some expressions. Question 3 is another example of writing some expressions. And then questions 7 and 8, which we jumped down to, again, is writing some expressions. However, they're getting a little bit trickier because they need to perhaps, as it says here, use some brackets. 9, 10, 17 and 19 are a little bit harder. 17 and 19 is when we're moving into some problem solving and reasoning type questions. A little bit of a checking for understanding. Nadine has 7 bags with X lollies in each bag, plus another 9 lollies. The total number of lollies is, if you can get the right answer for that one, you've learned something from this class. For question 5, the sum of Z and 6 is divided by 2. When written in algebra, what does that look like? And number 6, how can this number sentence be written using algebra? The sum of R, X, and Y is divided by 4, then has 7 and Q added to it. What does that look like? They're a little bit tricky. These are the answers. I hope you got something similar. As a bit of a ploughback, take the time now to think about the answers for these questions. What is a pronumeral? What does a variable represent? What's the difference between an expression and equation? And do we need to write a multiplication sign between a variable and a number? But what I don't want you to do is to go back and have a look at your notes. I'd like you to see if you can answer these in your own words, because that will give you a better understanding of what they represent. Pause the video before you go on to the next slide, because I'm pretty sure there might be some answers coming up, but I'd like you to define those in your own words. Nope, no answers. So folks, thank you very much for your attention in this first slideshow. As I said, this was the lesson that I missed, unfortunately, and so this video was purely to catch up and show you some of those important terms, definitions, and conventions when it comes to algebra. Please work through those exercises, and as it's said on there, make sure that you get me a copy of your completed work. Either you can take a photo or you can scan it and you can send it to my email, or you can use the Dropbox that's on the online classroom. Please make sure they get done, and otherwise, if you have any questions, make sure you send me an email. All this algebra information, I know that there's a lot, but it is quite important as we go forward. And as you'll see at the start of week 2 and week 3 will be pretty heavy when it comes to algebra. So hopefully we can work through those slowly and work through those together. I'll see you next week for our first live lesson on algebra, and I look forward to seeing you in the live lesson, and have a great weekend or rest of your week whenever you're watching this video, and I'll see you soon. Thanks everyone, bye.